Hello, Math 1. This lesson's 9.e, which is graphing linear inequalities. Now, if you remember, linear inequality in two variables is basically an inequality in two variables that relates, right, a line and a shaded region, all right? And this line we actually call a boundary line, okay? A solution then of an inequality in two variables is an ordered pair, okay, that makes the inequality true. Okay, just like an equation, it's no different. It's an ordered pair that makes an inequality true. Now, there is an infinite number of solutions to an inequality in two variables. And the solution exists in the shaded region, right? Or can be on the line if the inequality is greater than or equal to or less than or equal to. So anytime it's equal to anything on the line, right, could be a solution. So the first part they want us to do here is determine which ordered pairs are solutions to the linear inequality. All we're going to do is take each ordered pair, right? So the value of x here is 2, the value of y is 4, and we're going to substitute them into the inequality, and we're going to check for a true statement. So I'm going to replace y with 4. Is that less than negative 6 times 2 minus 3? Well, is 4 less than negative 12 minus 3, which is negative 15? Is that true or false? That is a false statement, therefore that's not a solution. Next one. If I take 2, is 2 less than negative 6 times negative 3 minus 3? Is 2 less than 18 minus 3, which happens to be 15? Is 2 less than 15? Yes. Therefore, that is a solution. The next one. Here's x, here's y. Replace y with 9. Is that less than negative 6 times negative 2 minus 3? Is 9 less than 12 minus 3? Well, here's the thing. 9 is 9 less than 9? And the answer to that is no. If it was equal to, it would be a yes. The last one here is 3 less than negative 6 times negative 6 minus 3. So is 3 less than 36 minus 3? Well, is 3 less than 33? Yes. Therefore, that is a solution. Okay, example 2. Determine which ordered pairs are solutions to the linear inequality 4x minus 5y is greater than or equal to 20. So same thing. Substitute the values of x and y in and check for a true statement. So here's x, here's y. It's 4 times 5 minus 5 times 0. Is that going to be greater than or equal to 20? Is 20 greater than or equal to 20? Yes, since it's equal to, that's a true statement. Next example. Negative 4 times 6 is minus 5 times negative 4. Will that be greater than or equal to 20? Well, it's 24. This is going to give you plus 20. Is that going to be greater than or equal to 20? Yes. That's a solution. Now, 4 times negative 2 minus 5 times 1. Is that greater than or equal to 20? Is negative 8 minus 5 going to be greater than or equal to 20? Right away, you know it's going to be negative. Therefore, no, it's not a solution. And the last one is 4 times 3 minus 5 times negative 4. Is that going to be greater than or equal to 20? Is 12 plus 20 going to be greater than or equal to 20? I would say 32 is greater than 20. Therefore, it is a solution. Now, what you have to understand in the next example, it says use the graph to determine which ordered pairs are solutions to the linear inequality shown here. So when I look at that linear inequality, This is the graph of that inequality. Now notice here, you have your boundary line, and then you have your shaded region. Any ordered pair that lies on the line in this case, because it's a solid line, is a solution. Any ordered pair that lands in the shaded region is a solution. So if I take the ordered pair 4, 2, if I plot it, does it land on the line or in the shaded region? Yes. Therefore, that would be a solution to the inequality. 2, 1. If I look, that's on the line. Since we're equal to, it's a solution. -2, 1. That's not inside the shaded region, so it's not a solution. 6, 5. Right away, if I look at that, in the shaded region, it's a solution. 1, -4. It's not on the line, it's not in the shaded region, not a solution. In -4, -3, same thing. Not on the line, not in the shaded region. Oops, this is not a solution. Sorry about that. Therefore, it's not a solution. Now, how do we graph these linear inequalities? Well, first thing we do is we graph the boundary line. Anytime you have an inequality that shows it's equal to, no one understands you're going to use a solid line, like such. If you are just less than or greater than, meaning you're not equal to, you're going to use a dotted line, like such. So once we graph our line, then what we're going to do is use a test point to determine which side of the boundary line to shade, right? If possible, use 0, 0. That tends to be the easiest test point to use, okay? But you can use any point on one side of the boundary line. If that point if the test point makes a true statement, you shade that direction. If it makes a false statement, you shade the opposite direction, okay? So let's take a look here. Right away, they want us to graph this. They already graphed the boundary line for us. So this here is your boundary line. And you can determine that just by saying my y-intercept is 0, -2, down 2, right 5, right? Draw your line. So that's our boundary line. Now, what we're going to do is we're going to use 0, 0 as a test point. If I plug 0, 0 into this, is 0 greater than or equal to -2/5 times 0 minus 2? Is 0 greater than or equal to -2? This is a true statement. Therefore, 0, 0 is in the shaded region. So I would shade on this side of the boundary line. Now the next one, 0, -5, up 3, right 4. Notice that this here is your boundary line. Now we have to determine the shading. So again, the line doesn't go through 0, 0. So we're going to use that as our test point. Is 0 less than or equal to 3/4 times 0 minus 5? Is 0 less than or equal to -5? That is false. If it makes a false statement, it should not be in the shaded region, which tells you to graph or shade the other side of the line. Okay? So again, if it makes a true statement, you shade over the line. If it makes a false statement, you shade away from the test point. All right? So now we go to graph these. If your line is in slope-intercept form, use the slope and y-intercept to graph the line. So here, the slope of this line is -4/5, which tells me I would go down 4, right 5. My y-intercept would be 0, 6. So I'm going to plot my y-intercept. Then my slope tells me to go down 1, 2, 3, 4 over 1, 2, 3, 4, 5. I'm going to determine, do I have a solid or dotted line here? Well, in this case, I have a dotted line because I'm not equal to. So I graph my dotted line. Now, my test point for shading, the line does not go through 0, 0, so I'm going to use 0, 0. Is 0 greater than negative 4/5 times 0 plus 6? Is 0 greater than 6? It is not. So the point 0, 0 should not be in the shaded region, so I'm going to shade the other side of the boundary line. Okay? Next one. Slope is 2/3. Y-intercept is 0, 4. Plot my y-intercept. I'm going to go up to right 3, up to right 3, and I'm going to graph. Here, this tells me I'm going to have a solid line, so I'm going to graph my solid line. Then, I'm going to look to use 0, 0 as my test point. Is 0 less than or equal to 2/3 times 0 plus 4? Is 0 less than or equal to 4? That checks out. Since 0, 0 makes it a true statement, I know that I'm going to shade on the side of the boundary line 0, 0 is on. And that would be the graph. And my last one. If you look at this, it is in standard form. AX plus BY equals C. 24 is divisible by 6. 24 is divisible by negative 3. So we're going to graph this using the intercepts. Find the x-intercept by letting y equal 0. So 6x is equal to 24. Divide by 6. X is equal to 4. 4, 0 is 1 point on this line. My y-intercept, let x equal 0. So negative 3y then equals 24. Divide by negative 3, y is equal to negative 8. So I plot 0, negative 8. 0, negative 8. Now, do I have a solid or a dotted line? Since we're not equal to, it's going to be a dotted line. And now I'm going to use 0, 0 as my test point. 6 times 0 minus 3 times 0. Is that going to be less than 24? Is 0 less than 24? That is true. Since that statement is true, 0, 0 is in the solution, so I shade this side of the boundary line. All right, that concludes this lesson. Hopefully it helped, and if you have any questions on this student practice, let us know.